In this video, we'll be looking at NCEA Level 1 Mathematics Common Assessment Task Algebra. And in this video, I'll be focusing on exam type questions where we'll be using index laws to simplify algebraic expressions. I've already covered laws of indices in my previous video. If you haven't already, please do check that one out. And in this video, we'll be applying those index laws to simplify algebraic expressions. So we'll quickly have a look at the first example. It says simplify 3y to the power of 4 whole thing raised to the power of 3. And in this case, you just need to know that power of 3 means 3y to the power of 4 is multiplied by itself 3 times. So it's repeated multiplication. So I can rewrite that as 3y to the power of 4 times 3y to the power of 4 times 3y to the power of 4. And power indicates how many times it's multiplied by itself. And in this case, it's 3 times. And then what I can do is I can multiply all the numbers together. So 3 times 3 is 9. 9 times 3 is 27. And if you look at the laws of indices, when I'm multiplying the exponents with the same base, the powers are added. So in this case, it simplifies to 27y to the power of 12. Now, in the assessment, you can use this method if you know that power means it's multiplied by itself that many times, in this case 3 times. Or if you're given like a power of 7 or 10 or 12, then it becomes like a little bit harder to write all of those 11 times or 7 times, depends on the power. So it's helpful if you know the laws of indices and use the shortcuts. So we can do the same problem using laws of indices. And if it says simplify 3y to the power of 4 whole thing raised to the power of 3, and if I know the laws of indices, we can use the shortcuts here. So 3 is raised to the power of 3, so I can write 3 cubed. And y to the power of 4 is raised to the power of 3. And using the laws of indices, I know the powers of powers, in this case, powers will be multiplied. So 4 times 3, and then I can simplify the 3 cubed is 27, and 4 times 3 is 12, so y to the power of 12, and we end up with the same result as the previous method. So your choice really. If you are comfortable with using the expanded form, please go ahead and use that. But I would suggest if you can use this method, the only common mistake you can make is not realizing that this is 3 to the power of 3. Sometimes students rush and write 3 times 3, which is 9, and that will give you incorrect answer. So 3 cubed means 3 times 3 times 3, which gives you 27. Second example. It says simplify 2a over 3b squared whole thing raised to the power of 4. Now I can do this using this method, expanded form, but I will try and use laws of indices, which is quick and easy way of getting the answer. So we'll stick to that one. So first we will need to apply laws of indices to get rid of the bracket. So in this case, as you can see, 2a whole thing is raised to the power of 4, as well as 3b squared, because they're contained in the brackets. So we'll remove the bracket by using laws of indices. So 2 is raised to the power of 4, a is raised to the power of 4, 3 is raised to the power of 4 as well, and b squared is raised to the power of 4. So powers of powers, we will multiply that, and then we simplify. So 2 to the power of 4 means 2 times 2 times 2 times 2, and that gives you 16. A to the power of 4, and 3 to the power of 4 is 81, and 2 times 4 is 8, so 81b to the power of 8. I would suggest if you can pause the video and try this yourself and see if your answer matches with this. So we'll have a look at the third one. It says 3n cubed whole thing squared divided by 4n squared. So this fraction is now multiplied by 2n squared whole thing cubed divided by 6 into n to the power of 4 squared. So what you need to do first is remove the brackets, and when you're removing the brackets, we'll be using laws of indices like we did in the previous example. So we know that 3n cubed whole thing squared will now read 3 squared n cubed times 2, and that is divided by 4n squared, because 4n squared is not squared in this case, so that's outside of the bracket, so that stays the same, multiplied by 2 cubed, so we've got 2 cubed, n squared times 3, so n squared times 3, And then we have got divided by 6. Remember, 6 is outside the bracket, so 6 is not squared. So be careful here. So 6 stays as is, but n to the power of 4 is multiplied by 2. So now you can see we have managed to remove the brackets, and then we will now simplify. So 3 squared is 9, 3 times 2 is 6, so n to the power of 6, whole thing divided by 4n squared, and that's multiplied by 8n to the power of 6 divided by 6n to the power of 8. And what we need to do next is simplify the fractions. So we'll start by looking at the numbers first, and then we'll look at the variables next. So in this case, we know that 4 can go into 8 2 times. So we can cancel those two and write 2. This 4 goes in 8 twice, 2 times, and then we can see 2 can go into 6. So I can cancel 2 and write 2 can go in 6 3 times. 3 2s is 6. And then now once I've done that, then I can see that 3 can go into 9 3 times. So 3 goes in 3 once, and 3 goes into 9 3 times. So what I've got here now is I've managed to simplify the numbers. So we'll rewrite whatever is remaining. So we can see that I'm left with 3n to the power of 12 now, plus n to the power of 6 times n to the power of 6. So if I'm multiplying the same base, the powers are added. So 6 plus 6 is 12. And that's divided by n to the power of 10, because we've got 2 plus 8 gives you 10. And then we simplify this further. So we can get rid of n to the power of 10, because there's 10 of those, and that will leave us with 2. So we're left with 2 on top, so n squared, and then finally we put these together, we end up with 3n squared. Hope this makes sense. I would suggest you can pause the video and try these questions yourself. Thanks for watching. I'll see you guys in the next video.